Hello everyone and welcome to my channel Geoverse, and here I'll be discussing some of the very important topics for various geology examinations like combined geoscientist examination, gate examination and so on and so forth. Today I'll be discussing three very important laws that are included in our combined geoscientist mains examination. They are Fick's law, Darcy's law and Fourier's law. Now you can ask me, why are these three different topics being taught together? The answer is, these three laws are very similar to each other, so I think it's not a bad idea to learn them simultaneously. So watch this video till the end. Here I have given the screenshots of the part of the syllabus of Combined Geoscientist Mains where you will find these three laws. For example, the Fick's law of diffusion is included in the section B of paper 2, that is geochemistry and isotope geology part. The Fourier's law of heat conduction is included in the metamorphic petrology, which is the section D of paper 2, and finally the Darcy's law is included in the section B of hydrogeology paper. First, I'll be discussing the Fourier's law of heat conduction, which was given by Joseph Fourier in the year of 1822. Now, what is conduction? Conduction is a process in which heat is being transferred through a substance by transfer of kinetic energy from one molecule to another. Now, coming to the law. The law states that a heat flux resulting from thermal conduction is proportional to the magnitude of the temperature gradient and opposite to it in sign. The statement seems a bit difficult to remember, right? Let me just simplify it for you with a very simple example. Suppose you have a cup of hot tea and you need to drink it as quickly as possible. What will you do? Number one, you may pour the tea onto a plate so that the surface area can be increased and the tea can be cooled down quickly. Number two, you can put the cup into the refrigerator so that the temperature difference between the tea and the surrounding be increased. More the difference, quicker will be the rate of cooling. And number three, if you don't have any time constraint, just leave it there and it will be cooled after some time. So if I summarize the thing, then that heat transfer, for example, Q is directly proportional to three factors. They are area, time and temperature difference with the surrounding. Okay. Now keeping this in mind, let's derive the formula of Fourier's law. First, let's have a look on this diagram. Here, the heat is being conducted between two plates of cross-sectional area A with temperature T1 and T2 respectively. And T1 is greater than T2, thus heat will flow from plate 1 to plate 2, that is from higher temperature to the lower temperature. The distance between these two plates is represented by delta X, and the temperature difference, that is T1 minus T2, is represented by delta T. Now let's derive the formula. From the previous example of the cup of tea, we have seen that the heat transfer Q is proportional to area A, temperature difference delta T and time, that is small t. And another quantity which controls the heat transfer is the distance between two plates, which I have shown in the previous figure, that was referred to as delta X, and this is inversely related to that of the Q. So if I combine all this together, we can write that Q is proportional to the area multiplied by delta T, that is temperature difference, multiplied by time divided by delta X, that is the distance between the two plates. Alright, it is also can be written as Q equals K, which is the proportionality constant that can be defined as the heat conductance multiplied by area multiplied by difference in temperature, that is delta T, by delta X into time or small t. Generally it is written in differential forms, so we can write it as Q equals K A d capital T dx into time. Now, if I divide the left hand side, that is Q, with area and time, we will get another very important quantity which is known as the heat flux. We know that flux of any quantity is basically the quantity divided by area and time. So heat flux will be the heat transferred divided by area into time. This is altogether defined as Qx. So finally, we are having the form of Fourier's law as Qx equals K d capital T by dx. Now, there is a small catch in the final form. Here we can see that there is a negative side in the right hand side. Now, what does its negative sign represent? This negative sign is nothing but to represent the fact that we are moving from higher value to the lower value, that is, we are moving more and more towards the origin. That's it. As we have completed the Fourier's law of heat conduction in details, the rest two laws will be very easy to understand. So let's jump onto the Fick's law of diffusion. This law was given by Adolf Fick in the year of 1855. It explains the diffusion process, which is the movement of molecules from a high concentration region to a low concentration region down the concentration gradient. There are basically two laws of Fick, the first law and the second law, among which the first law is very similar to that of the Fourier's law of heat conduction. It states the movement of solute from high concentration to low concentration across a concentration gradient, and the mathematical formula states that capital J is equal negative capital T d phi dx, where J is the diffusion flux, capital T is the diffusivity, phi is concentration, x is position, and altogether this d phi dx term is the concentration gradient. Now coming to the second law states that the concentration of diffusing element is a function of space and time both. And we can get this second law by combining the continuity equation and the first law. The mathematical formula is as follows: del phi del t is equal capital D del square phi del x square, where d is the diffusivity, t is the time, x is the position, and phi is the concentration. Finally, coming to the Darcy's law, which was given by Henry Darcy in the year of 1856. This law governs the flow of groundwater through a porous medium when the flow is laminar in nature. The Darcy's law simply states that the velocity of the flow through the porous media, which is also known as the Darcy's velocity, is directly proportional to the hydraulic gradient. Mathematically, the Darcy's velocity, or Vd, is equal to minus K, which is the hydraulic conductivity, into dH dx, which is the hydraulic gradient. Again, it should be noted that this Darcy's velocity term can also be represented as hydraulic flux, because it is nothing but the volume of water that is being transferred per unit time per unit area. The Darcy's formula can also be represented with respect to the net discharge, because the Darcy's velocity Vd is nothing but the discharge per unit area. So if we replace the Vd term with the discharge per unit area, we can express the Darcy's law with respect to discharge. This was all about the Darcy's law. Now we'll be coming to the comparison of the previous three laws. Finally, to summarize all these three formulas, we can formulate a generalized formula, which is the flux of the quantity we are dealing with is equal to the negative sign of a constant term multiplied by the gradient of the quantity that is causing the movement. For example, in case of Fourier's law of heat conduction, heat is the quantity which is being transferred and temperature is the quantity which is causing the transfer. So the formula will be heat flux equals to the negative of heat conductivity, which is a constant, multiplied by temperature gradient. Similarly, for Fick's law of diffusion, it is diffusion flux equals the negative of diffusivity multiplied by concentration gradient, and in case of Darcy's law of groundwater flow, it is the hydraulic flux equals negative of the hydraulic conductivity multiplied by hydraulic gradient. And lastly, I have added one question regarding the Fick's law of diffusion from GSI Prelims 2022, and want to draw your attention towards the fact that though the laws like Fourier's law or Fick's law, they are not included in the GSI prelim syllabus, it cannot be guaranteed that no question will come from this domain. So be prepared for that. Now coming to the question. Which one of the following crystal growth mechanisms can be explained by Fick's law? There are several options, but the last option is diffusion control growth. We have Fick's law in the question, and we know that Fick's law is all about diffusion. So the final answer would be the diffusion control growth. Okay. Now I have some questions for you. Just comment down below what are the dimension and units of thermal conductivity, diffusivity and hydraulic conductivity. These are some of the very common and important questions for various competitive examinations. So all the best. Thank you so much.